What's wrong?
Noise.
Yes. I'm sorry. Sayum, I'm sorry about the noise, but Brendan has every right to be here. All right. Yes, indeed. Okay. Newton's second law. Force is the rate of change in momentum. Give an example of this law.
Two cars hitting one another.
No, keep it simple.
You know, something falling.
Being thrown.
Yeah, something falling. So a ball will have a weight force pulling it down, causing its momentum to change. Whatever. Look at this. Calculate the impulse when... Oh, my goodness.
Do we even need to go through this?
Yeah, what is this? How do you get the impulse if you know the force and the time? Yeah, what's the formula? I equals...
If this...
Oh, it's not actually there. Well,
It's changing momentum over time.
I'm just wondering if it's here in the book so I can show you. There it is. There it is there. Impulse. Look here, Brendan. Impulse is the force multiplied the time. So in this example here, the impulse will be the force multiplied the time, so the total is 9. 9. I'm not even going to write that down. Determine the effect of this impulse has on the velocity of a stationary mass of 2 kilograms. So, what is the velocity at the beginning? 0. And afterwards, we don't know. And what's the mass? 2. So you can use this formula. Impulse is the change in momentum, so that's mv minus mu. We just worked out the impulse. What was it? 9. What's the m? 2. The v? We don't know. The u? 0. So v is 4.5 meters per second. Alright? Done. The 2 kilogram mass continues until it collides with a 4 kilogram mass travelling directly towards a speed of 3. What's their velocities afterwards? So what formula do we need here? Momentum. So this one here, what's its mass? 2. This one here, its mass is 4. But it's going 3 towards it, and this is going 4.5 that way. So the momentum beforehand will be 9 minus 12, multiply them, equals, what's the mass afterwards when they collide together? 6x. So x would equal minus 0.5, right? So after they collide, which way is the blob heading? To the left. Two men carry a uniform straight wooden pole of length 8 meters and 16 kilograms. One man holds the pole 1 meter from the end, and the other man holds it 2 meters from the other end. Draw the diagram, calculate the forces. So it's 16, 8, 1, 2. So if I draw that, it's 16 in total. There's 1 from this end, 2 from this end. The weight is in the middle, and the weight is 16. No, it's 16. Yes, 16g. This is 1. This is 2. In the middle is 4 meters. So how big is this one? 3. And then this one here, 2. And there's a man here pulling it up, and then one here. Okay, so what do we need for this problem? Come on, wake up time. Wake up.
What do they need?
This is a new one, the next one. Keep up, Curdy. We're going with it.
R and S.
How can I find the R and the S? What do I do?
R plus S equals 16 times
Good.
8.
R plus S equals 16g. And the turning force should be 0. So if I take this here as the turning point, clockwise or anti-clockwise? Anti-clockwise, so it'll be 1 or. Clockwise or anti-clockwise? Clockwise, so it'll be minus 4 because it's 4 meters to here. Multiply 16 G. Clockwise or anti-clockwise? Plus, what's the distance? 6s equal 0. So now you have r plus 6s equals 64g. Two equations, two unknowns. Get solving them. So we subtract them and get 5s equals 64g minus 16g. What's that? 48? Is it? 48g?
Yep.
So please do 48 times 9.81 divided by 5.
94.176.
94.176 newtons. And then to get the, if we do 16 times 9.81 minus that answer will give us the R.
62.784.
62.784 newtons. And there you go. We've now drawn the diagram and calculate the two forces, leaving us only with one part C left to do here. Okay? A weight is dropped from a height 200 meters from a helicopter that's moving upwards with velocity of 4 meters per second. So you have a helicopter going up at 4 meters per second, and then somebody drops a weight out. What is the velocity of the weight just before it hits the ground? So let me draw that for you. Here's the weight. Now believe it or hey, it's what? Right. This is thrown out of the helicopter. At the beginning, what's its velocity? It's up 4 meters per second. Now listen. Think about this for a moment. If you're in a car and it's moving at 10 meters per second and you jump out of the car, you will be starting your journey at 10 meters per second. You won't be coming out of the car at rest. Definitely not. So if this is thrown out of the helicopter and the helicopter's going up with 4 meters per second, when it comes out, it's not at rest. It's actually going up 4 meters per second. But then it'll very quickly stop and fall down. Okay? If you want to think about it another way, it's like there's a person floating here and they throw this ball up in the air. The height is 200 meters and we would like the V. Well, what formula could I use? I could use V squared equals U squared plus 2AS. So V squared equals 16 minus 9.81 times 200. I believe it's 200.
And that'll take into account the small distance it travels.
Yep, it sure was. Yep. So, yeah, please type that in on the calculator. So V is the square root of that number there.
That's a negative number.
It should be, because it's going down when it hits the earth. So it should be negative. Oh, in the inside?
Yeah.
For real?
Of course.
Oh, sorry, folks. I left out a minus sign. Hey, I left out a minus sign on my 200 because it's 200 below where it started.
Oh, I think the minus sign would be on the 9.81.
And that minus is on the 9.81, yeah.
Okay, that's
62.8.
62.8 meters per second. And of course, with a square root, you have a plus or a minus. So which answer do we take, the plus or the minus? Well, we should really say it's minus because it's going down into the earth. All right. Yeah.
So it's minus 2.
Wait. Say you. Scroll up. Which, this one? This one? Or just want this one? Which do you need, Sayun? Do you need this question or the last one? This one here, okay. You want to write the formulas down, is it? Do you need me to go? Hang on. There. Okay. Well, I think the last part was, what was the last part? I'll just get it up here. It's okay? If error resistant, okay, so the last part is the time. So for the last one here, we want the time. So we know the U, we know the V, we know the A, we know the S. So what would be the easiest formula to give us the time?
Half a...
V equals U plus AT. So you could just say T equals V minus U over A, which would be minus 62.8 minus 4 all over minus 9.81. What's that?
6.8.
Wait, what did they throw out of the helicopter?
Who cares? It was, all you need to know was the helicopter was going up at 4 and it was 200 meters above the ground.
Can you move
So you can see this?
What?
No.
I'm moving to the left as well, and you're turning projecting to the left, aren't
he
you?
means in the...
I know what he means.
Okay, I thought...
Yeah.
There.
Are you done?
I don't know about you, but I'm feeling pretty done right now.
Are we done?
Let me think.
Please.
But look, just give me.
It's yours. I have to put it back in, but you're not deciding.
Right, please. I just want to check something. What's the last week of classes? What date? I just need to make sure I'm on track.
11th of April.
No, the ultimate last week.
I don't know.
The TV shows come back on Monday.
Is it the end of May, or do you have the exams?
Yes, 30th.
Yes, okay.
Yeah.
So hang on just 1 second, please. This is 1 week. 2, 3, 4, 5, 6, 7, 8, 9, 10. But we lose 1, so 9. I just need to make sure I have enough time to do revision each week. So we have 9 weeks of revision left. But we've only done...
3.
Please stop moving while I think.
We did 4.
Don't move.
Okay, with this 3 sections.
No, don't talk. Don't move. Just let me think. We have part 1, 2, 3, 4, 5, 6, and we have A and we have B. So this is done, this is done, this is done. Good. Right. So if this took 1, 2, 3, 4, 5, 6, 7, 8, and I said there's 9, and I better leave one spare just in case. Alright, look, the way things are with the amount of time that's left, you know that it takes me more than 1 week to do a full set of questions. Like for example, today we did half of the long
Questions
yeah. Now we did get all of these done, but that took like 2 weeks or something for each of them. Well, nearly 2 weeks. This one took 2 weeks, this took 1 week, and this took 1.5. So I cannot be given more than 1 week for each topic. So unfortunately, I have to consider this revision done for part 1. Okay? Number 1, I have to consider it as fully revised now, although there's still more questions. And I welcome you to look at the questions and try them.
Can you give...
I'm putting this on moving tonight. I forgot to last week. Number 2, I'll do this one next week, which is the heat. And then after that, stop moving, Brendan. Don't move. After that, I'll do the long electricity questions. So then, will we get this finished before the Easter break? Do we have 2 more Wednesdays?
2 more Tuesdays here.
2 more Tuesdays, we do.
Yeah.
So this will be finished before Easter. And then your physics labs will also be finished. So then after Easter, we'll have 4, 5, and 6 to do on Tuesdays. And we won't lose any time with lab reports. So on when else do we have physics? On Thursday and Friday.
Yeah.
On Thursday and Friday, we'll do the atom for the last few weeks. Okay, so my plan now is after Easter, Tuesday, 4, 5, 6, Thursday and Friday will be the atom. And we'll have no distractions with the lab reports because they'll be all finished before Easter anyways, okay? Please, I'm serious. I do worry sometimes about how much revision is going on at home and attendance too. Yes? So just a quick check. What grade do you need in physics, just as I go around the room? Do you know? You need an A.
I need it.
Brendan, what grade do you need in physics?
Oh, I need an A, thank you.
Do you really need an A? For real?
I really.
Actually, no. It's math that I need an A.
So the physics could be theoretically a B. Sayun? B. Ali, do you know? C. B or C? What does C do?
No, C.
C!
Yeah, it's C, right?
Too easy.
Yeah.
And what for you? C? Yeah, well don't get, but even if it's a C, you can still screw it up. Don't worry. The potential for students to screw it up is still very big. You could still screw it up. Don't screw it up. You too, okay? So don't just think because it's a C you can go
No, I'm
easy.
not thinking that way. I'm just thinking I have my math exam,
Yes,
and I have 2 lab reports,
yes.
and I have my derived exam.
Oh yeah, I forgot about that. Oh yeah. You have a lot of work.
Screwed now.
What does Joseph need? He needs an A. He needs an A. Sorry, Brendan, Joseph and Avenue look very similar.
We already went through that phase last semester. I'm used to it now.
Yeah, you do look very similar. All right.
All us three are the
How?
I don't know.
How?
I don't know.
Complete opposites.
They're usually absent. That's how they look similar.
Oh yeah.
Yeah.
Oh, you don't know how they look, so you mix up with the names.
This is how I picture them, like this. This is what they look like to me. Yeah?
Air.
Yes. This could easily be Joseph. Yeah. Right, okay. Oh, I should have stopped recording that.